Okay, perfect. Yeah, so I'm Mario from Germany. I'm working at the Institute of Geoinformatics. So what geoinformatics is, you heard it in the talk before. So normally we are doing like building software for GIS users and also training students in GIS. But we always had like a program at our institute where we are going to schools and teaching GIS use, doing spatial data analysis. And this is where all these projects come from. Normally, I would be in a school, being a teacher, so I'm not a software developer by my studies. So everything I learned doing, or in software development, I learned doing, working with Blockly, either on the Blockly side or creating this block-based environment, which is pretty nice, I think. So I just want to give you a brief overview about senseBox and the Open Sense Map, then our Blockly implementation, the tutorials and the tutorial builder we have in our implementation, and what we have planned for our future work. So the senseBox is funded more or less like over 10 years ago. We were going into schools with regular arduinos. We were taking a lot of stuff with us like sensors, other hardware, displays, SD cards, GPS modules. And we were building in workshops a measurement device to get out and collect data and do data analysis later. Teachers then said, okay, that's kind of nice. We want to do it also integrated into geography classes. How can we get all this stuff? So how can we get all this hardware? And this led to the toolkit where we said, okay, this is the typical hardware we are using. This was first some kind of a box which was taking like normal hardware, normal Arduino hardware you could just buy everywhere. We just put it together and gave it to the teachers and said, okay, this is what we are using. And now we are also producing own hardware with a local producer in Germany because it enables us a little bit more to integrate new sensor, new modules, but still keeping everything open. I was speaking about data, so we were collecting a lot of data, either from shorter measurement periods, but also from measurement devices which were set up permanently at the schools, for example, or at other buildings. So we needed some kind of data platform for it, where the data needs to be or can be stored. So we created the Open Sense Map, which is now being used by over 10,000 users all around the world, mainly in Germany and Europe. And there are a lot of citizen science projects actually using the platform to collect data. So the platform itself is totally open. You can use it with any hardware you want. So there are even professional scientists using professional scientific measurement stations sending data to the Open Sense Map to just use it as a data storage, to get the data later. There's an open API. There are a lot of scripts for R, for QGIS, and so on to get the data and work with the data later. So we now have a lot of different hardware. Especially for the hardware, we try to keep it as open as possible, so everything is under an open hardware license. We try to keep it completely compatible with stuff from Adafruit, from SparkFun, so that you can interchange this, that you can add our hardware to their hardware systems, and also the other way around. But of course, we have some kind of a limit in it that we are saying, okay, we put our hardware in our boxes to make sure that we can get this hardware, produce this hardware, and to do this also in Germany. We now have 3 different microcontrollers. We will probably have more in the future, and they are based on different processor architectures. So we now have reached over, I think, 100,000 users in all kind of formal and non-formal education. So senseBox hardware is being used in primary, secondary, higher education, but there are also like universities, the ETH in Zurich, for example, are using them, doing their geography classes at university, and also in other contexts like hackathons or at schools or at workshops in formal and non-formal education. What is the typical workflow when the people are working with the senseBox? So of course, they first construct it. They're using the hardware. They're taking out the microcontroller, they're thinking about, okay, what kind of measurements do I want to achieve? They are choosing different sensors. They code the device with our Blockly environment. They connect to an IoT platform or save data on an SD card or anywhere else. Connect to another phone app via Bluetooth. So there are different possibilities. And later they are analyzing this data to get some kind of knowledge from the data. And here are some examples. So the more local examples, like the typical gardening kit. So they are measuring soil moisture, automatic planting, or plant watering. They are measuring with the distance sensor. They are calculating the amount of cars passing by, for example. But there are also, studies. This is a study often occurs in geography classes where thinking about, okay, we can feel the heat island effect inside our city. So Münster is like a city with 300,000 inhabitants. There are a lot of people going by bike from outside inside the city. It's a pretty bikeable city, so there are more bikes than people inside the city. And the kids are often questioning, okay, can we feel like or can we measure the heat island effect, which we can feel when we are going around by bike? So if you watch to the data visualization, so they were going around by bike from the inside of Münster on different routes, you can pretty see one effect. So I will move to the next slide. Okay, now we should have a static image. Oh, perfect. Okay, so you can see that inside the city there are some green spots. And one of these green spots is like the promenade, our bicycle highway inside the city. So it's a street where only bicycles and pedestrians are allowed. It's pretty. It's like 50 to 200 meters wide, and there are only trees. And you can feel that it's better to drive there instead of the bigger cities. So with the possibility to get your own data, you can get from data to knowledge and do the whole process of a scientific research project in small, because you are able to build your own device, code the device, and also to collect data and analyze data later. So this is our implementation of the Blockly interface. We had a first one, I think, 2016, which was a fork of the Ardu Blockly project. But I think the Carlos is now at Microbit and not maintaining it anymore. And so we said, okay, let's start a complete rebuild in 2020, because there was so much going on also at Blockly, and that you say it makes sense now to switch. So we completely rebuilt the application. We are always displaying the generated Arduino code to show that there is something happen behind the scenes, so that it's not hidden. One thing we also noted, for example, that people are not using or not hovering over the blocks to view the tooltip. So we have some kind of small tooltip viewer here. So if you click on a block, the tooltip will be getting rendered and directly shown instead of hovering to the block to be visible. If people want to move later to editing the code, they can switch to a code generator, so they can directly work in the code if they want. But we also often get questions, can we now also make the switch back to blocks? And we heard a lot of approaches, so we will definitely have to look into it and get some new inspirations. So this is the general overview about the infrastructure. So on the one hand, we have the web interface. We have an online compiler service so that the schools doesn't need to install any software. So it's completely working in the web. The generated Arduino code gets sent to the compiler service. You will get the complete compiled binary file, which you just can drag and drop to your microcontroller. And it's completely open so that you can extend it also for other boards, like Arduino board from Adafruit or from SparkFun. Then, of course, we have some kind of API behind it to manage stuff about storing tutorials, storing user data so that they can save the project and also share the projects with each other. The key features are like, created a complete new Arduino code generator to be able to structure the code. We have a multi-board support which can be extended by other boards, so it's not limited to the senseBox hardware. We have a static variable typing and also showing the type inside the block so that it's also not hidden to the users. And we have like tutorials and the tutorial builder, which I explain later. And we are eager to integrate new blocks all the time. So I already spoke with Evan from MIT about integrating new blocks so that you're also possible that there's a possibility to send data to a self-built app with the App Inventor. This is the basic structure of the code generator. You often have like pre-made libraries, as we are also using like, or that we are supporting sensors from other manufacturers, so that it's pretty straightforward to add new hardware and new blocks to the sensors. The code generator itself helps us with the code dictionaries to structure the code because sometimes there's code which only needs to be run once in the loop, so it would be it only needs to be once there, otherwise the code crashes. But also in the code generator, there still need to be some work to make it perfect and extendable. The board definitions, so you can extend the amount of boards inside the application while adding just new board definitions to a JSON file. So of course need to have some kind of title, and there's a compiler flag, which is important because you will need to send the compiler flag also to the compiler, so that the compiler knows for which board do you want to compile this code, and you will define all the pins which are able to connect sensors via different protocols. Currently, we have like a lot of different IoT blocks. You directly can send data to the lower network. So there's the Things network, for example, in Europe, which is pretty strong. You can directly use it. There's MQTT. There's the OpenSense map. There are other protocols where you just can send data to other REST APIs to ensure that you can use more or less the service you want to use. And doing the work, we also noticed that it's pretty nice to have some kind of tutorials inside the system, that you don't have to teach all the time in front, and the users can do a lot of stuff on their own. So we created some kind of tutorial system. The tutorials are completely open. They can have different steps. They can have different tasks inside one tutorial. And it's completely up to the users about creating the tutorials. Of course, there are pre-made tutorials, but we are also open and hoping that other users are creating tutorial, which is also happening. The tutorial structure is also a JSON file, so there's some kind of flag that it's public or not public. We have some kind of a user. There's a difficulty. You are predefining the hardware which get rendered when you're opening the tutorial, so that the users see what kind of hardware you need to fulfill this tutorial, or if you should have already completed another tutorial, this can all be done here. We are still on XML for saving the blocks. This is work in progress to switch to JSON there to have it complete. But no one wants to create JSON files by typing all the stuff. So we created a tutorial builder which is right in the application. So you can log in with a user account. You have like the possibility to select from the hardware. You can write text in Markdown. You can directly provide some kind of Blockly samples. There's another workspace where you can just click and drag and drop some blocks together to have a sample. This can either be a sample if you want to give an instruction, but this can also be a sample to have like a sample solution. Of course, we have only one solution. Most programming tasks, you can find millions of solutions. So this is also a work in progress to support multiple solutions. The link or the tutorial is then shareable via a link directly, and every user can do it. If you want to be this tutorial on the tutorial page, you can also submit it for review so that we can have a look at it, or the community can have a look at it, and then we can set it public and everybody's able to access the tutorial. What is the current and future work? Of course, a lot of work on the tutorial system, especially in the adaptive tutorial path, so that you're also able to move between the steps, that maybe the tutorial itself will also adapt itself on the learner's need. A lot of teachers are asking for a classroom mode because they like and love the classroom mode in Tinkercad. That they can organize their students in a classroom. We are eager to integrate new hardware. I'm also thinking about creating a white label solution for non-senseBox hardware, so that we can integrate all the stuff from Adafruit, from SparkFun, and all the microcontrollers which are around. And in a study project at university, in my teaching, we are also working on a Blockly for data science, so that we can also do the last step with a Blockly-based application instead of using like a general GIS like QGIS or anything else. Thank you, and
any questions? All right, one back there.
I was just curious about the, you talked about the build servers, and I was just wondering, had you looked at trying to do all of that in the browser, or was it just not technically feasible because of the compilers you need, or?
Yeah, so currently we're only using the solution that we have, like the online compiler, so we can't do it in the browser. I don't know how MakeCode is actually doing it, because they are compiling it somehow, so they don't need an online compiler service. I was looking around if there's something similar for compiling the Arduino code, but I haven't figured it out perfectly. So if there's a solution, I'm happy to hear about it.
Yeah, happy to follow up on the MakeCode compile chain.
Okay, perfect.
I saw in one of the slides you showed MQTT, the connectivity, LoRa, SigFox. Mm-hmm. So what are the other band, like WWAN, Bluetooth? How many other protocols do you support?
Okay, so in terms of hardware, there's like a Bluetooth module. There's a classic Ethernet model if you want to go back to the cable, or Wi-Fi, and LoRa. So we have these four possibilities. We were working on NB-IoT, but it's quite difficult in Germany with all the regulations and stuff. So these are the four possibilities. Of course, you can just use HTTP and send data to REST API. But this is basically it at the moment.
That's what I was curious. Would that work in US?
Sorry?
Will that work? Some of those protocols, like LoRa, I'm not sure, like SigFox, we tried and they didn't really work in many regions in US.
I think LoRa is also working in the US, but on a different, bandwidth. Okay. I think in Europe it's like 868, and I think in the US it's 915 megahertz or something. So generally it should work.
Okay, thank you.